Hey everyone, welcome back to Context Window. Today, we are tackling the defining AI paradigm shift of 2026, context engineering and the architecture of situational intelligence. For a long time, the tech world was totally obsessed with just building bigger brains. We wanted more parameters, more compute power, massive data sets. But we've recently hit this collective aha moment. We realize that even the absolute most sophisticated neural network out there is functionally useless if it lacks the specific real-world context needed to solve a problem right in the moment. We filtered the noise from all the latest research to show you exactly why this technology is an absolute game changer. Because let's be real, here is the status quo problem we've all faced. Why do really smart AIs suddenly get dumb? If you've ever used a model for a complex, multi-day workflow, you've definitely hit what engineers call the invisible wall. The AI starts suffering from these memory leaks, right? And a conversation that started out totally brilliant just slowly degrades into this generic, confused mess over time. Well, context engineering is the ultimate fix for that invisible wall. And here's the kicker. We have moved completely past those older eras of AI. Think about it. Pre-2020, models were basically frozen in time, right? Totally constrained by a strict knowledge cutoff. Then, from about 2020 to 2023, we had native RAG. That let them look things up in a library, which was cool, but hallucination rates were just off the charts. Lately, we've been stuck in the prompt engineering era, obsessing over the exact wording of our questions, which inevitably leads to context rot, as the AI slowly forgets our huge list of rules. But now, 2026 and beyond, we realize AI operates best in a dynamically engineered ecosystem, constrained only by its token budget. Okay, to really grasp this shift, picture this scenario. Imagine walking into a massive, bustling commercial kitchen. You march right up to the head chef and just yell, "Bake a cake at 350 degrees." But here is the catch. The chef has absolutely no ingredients on the counter, the pantry's locked, and they have no idea that the person you're actually baking for has a severe gluten allergy. Obviously, that setup is doomed to fail before the oven even turns on. That kitchen disaster, that is exactly how the old way of AI worked. You, the user, had to play the micromanager. You had to manually check the pantry, dig up the ingredients yourself, and write out every single allergy constraint in this massive, unwieldy prompt. But context engineering, that's the AI way. Think of the system now as acting like an executive chef. Instead of begging the model to remember a list of rules, you design the entire kitchen environment. You source the ingredients, you organize the pantry, and you set the stage so the AI literally wakes up with a complete detective case file ready to succeed from second one. Let's actually put this into practice with, say, a holistic AI kitchen assistant. If you ask it to make dinner with leftover spinach and chickpeas, a context-engineered AI doesn't just blindly guess a generic recipe. First, step 1, it checks its long-term memory and sees, oh, this family avoids spicy food. Step 2, it accesses the environment layer and notices it's freezing outside tonight. Step 3, it uses its tool layer to scan your smart fridge, realizing the spinach is expiring today. And finally, step 4, it synthesizes all of that into a master plan, recommending a hearty, non-spicy spinach and chickpea stew. See? That is true situational intelligence. So how does it actually do that? Let's look at the 5-layer context stack and peel back the architecture of the situational intelligence. These 5 layers literally define how an AI perceives its reality. I like to assign them roles, right? So layer 1 is the system prompt. That's the guardian, setting the persona and the hard boundaries. Layer 2 is the tools, essentially the hands, letting the AI actually take action in the real world. Layer 3 is memory, which acts as the persistent self across multi-day chats. Layer 4 is retrieval, acting as the navigator to pull in external knowledge without causing that dreaded context rot. And finally, layer 5 is the state and environment. That's the anchor, grounding the AI in the absolute now. And guys, a massive, massive leap forward in layer 2 is the Model Context Protocol, or MCP. The best way to think about this, it's the USB-C for AI. It's this beautiful universal connection standard that gives the AI its hands, letting it flawlessly plug into any file, any database, or any API. And the best part? No custom integration code required. It just works, instantly bridging the gap between the AI's brain and your actual data. Now, if we look under the hood for a second to see the technical mechanics of this working memory, we run straight into the mathematical bottleneck of attention. In this explainer, we really want to grasp the why, not just the how. As you feed the model more of that environment data and history we just talked about, the number of tokens, which is represented mathematically here by the parameter L, grows substantially. Basically, L is just the sheer volume of data sitting in that context window at any given moment. But here is the core engineering challenge, and it's a big one. The computational cost doesn't just grow in a straight, linear line. It scales quadratically with this length, L squared. This quadratic cost nightmare means that if you just dump everything into a massive context window, the model will literally choke. Even top-tier models will just completely lose track of crucial facts if they get buried somewhere in the middle of a massive document. So how do engineers solve this quadratic cost nightmare? Through a highly effective process called compaction. Instead of lugging around this massive bloated transcript that just eats up the entire attention budget, compaction steps in and perfectly summarizes the history. It distills the critical details and resets the context window with a high-fidelity summary. This way, the agent maintains its momentum without drowning in old data. It's a lifesaver. And because of this math bottleneck, we no longer just look at the advertised size of a model's brain. That number doesn't mean much anymore. We measure models by their maximum effective context window, or MECW. This is the actual practical limit where accuracy holds up before the model starts forgetting things. And as you can see, top-tier models like Llama 4 Scout, GPT 4.1, Claude Opus, and QN3 Coder really excel here, holding on to vast amounts of context with incredible precision. Now, if you're a developer navigating these exact constraints today, you've got 3 top scaffolding frameworks to orchestrate all this. LangGraph is amazing. It gives you precise production control by treating agents as state machines. Then there's CrewAI, which is fantastic for rapidly prototyping a whole crew of specialized agents with distinct roles. And of course, LlamaIndex is your absolute go-to for contextual retrieval when you're dealing with massive, messy libraries of unorganized data. All right, so what is the evolution of this stack as we head toward 2028 and beyond? Welcome to the era of agentic context graphs. The immediate future is all about understanding the why, not just the what. We are moving toward cross-agent context graphs, where an entire company's army of autonomous agents will share a unified operating logic. They'll understand past precedents, share tribal knowledge, and proactively predict risks before a human even thinks to ask. It's like having a hive mind perfectly tuned to your specific environment. And that brings us to the core realization. Intelligence is no longer something a model is, it is something a model accesses. That wraps up our deep dive into context engineering. If this gave you a bit more clarity, or if it expanded your own context window, please share this. I've added the links to the resources mentioned in this document to the description below so you can check them out yourself. We're building this channel on your curiosity. If you have ideas for the next topic we should feed into the engine, drop a comment below. See you in the next one.